Question number 66, which says that which of the following orbital overlap results into formation of bond with highest bond energy, and we have four options with us: sp3, sp3, sp2, sp2, sp3, sp, and sp and sp. So first I will talk about the overlap for sp3 and sp3. So this is the sp3 hybrid orbital and this is another sp3 hybrid orbital. And if I talk about the sp2 overlap, this is sp2 and this is sp2. And if I talk about the sp and sp overlap, so it will be like this. So sp3 orbitals are longer and whereas sp orbitals are shorter. Why? Because sp orbitals are more close to the nucleus. So if you see that the bond length in the case for sp3 overlap is highest. So this is the increasing bond length. So, and bond length is inversely proportional to bond energy. So the bond energy order will be reversed. So this is the order for bond energy. Because lower is the bond length, higher will be the bond energy. So sp-sp overlap will be having the highest bond energy. So option number 4 is the correct answer. Moving on to the next one, now we have question number 67, which says that which among the following has highest boiling point. So boiling point depends upon the intermolecular forces of attraction. So higher is the intermolecular forces of attraction, higher will be the boiling point. So if I see among the H2O, CH4, HF and NH3, H2O has the highest boiling point. Because the extent of hydrogen bonding will be highest in water, because the water molecule is forming 4 hydrogen bonds and the extent of hydrogen bonding is very high. So H2O will have the highest boiling point. So option number 1 is the correct answer. Moving on to the next one, we have question number 68, which says that the separation of electron is relatively easiest in. So we have 4 options with us: excited H atom, excited helium plus ion, excited lithium 2 plus ion, and excited beryllium 3 plus ion. So the separation energy is equal to 13.6 into Z square by N square electron volt. So lower is the separation energy, easier will be the separation of electron. So we will calculate one by one for all the 4 cases. So in the first option, the separation energy will be equal to 13.6 into Z. Z for hydrogen is equal to 1 to 1 square and N we have been given is 2. So this is 2 square. So it will be equal to 13.6 divided by 4 electron volt. So I hope student this is clear to you. So next we have for helium plus ion. So for helium plus, Z is equal to 2. So 2 to the power 2 and N we have been given that is 2. So it is equal to 13.6 electron volt. Now come to the third option. So in this case, we have lithium 2 plus ion and Z here is 3. And N we have been given that is 3. That is equal to 13.6 electron volt. Now we have the fourth option for beryllium 3 plus ion. So for beryllium, the Z is equals to 4 and N we have been given it is equal to 4. in this case also the separation energy is 13.6 electron volt. So the lowest separation energy is for the excited hydrogen atom. So easier will be the separation of electron. So option number 1 is the correct answer. So moving on to the next one now, we have question number 69. So it says that the velocity of an electron, if its de Broglie wavelength is equal to the distance it travels in 1 second. So what is the expression for de Broglie wavelength? So we have de Broglie wavelength is equal to h by mv, where m is the mass of the particle and v is the velocity of the particle. So in this case, we have been given the de Broglie wavelength is equal to the distance it travels in 1 second. So what do you mean by the distance traveled in 1 second? So it is basically the velocity. So the lambda is equal to v. So we can substitute here v is equal to h by mv. So it will be v square equal to h by mv. So simply v will be equal to under root of h by m. So it was a very simple one. So option number 4 is the correct answer. So moving on to the next one, we have question number 70, which says that the first and second ionization potential of magnesium are 737.76 and 1450.73 kilojoule per mole respectively. So the energy required to convert all the atoms of magnesium to Mg2 plus ions present in 24 gram of magnesium vapors. So we have been given the first ionization potential, means first electron is removed from Mg and Mg plus is being formed. So for this, the IP1 we have been given, that is 737.76 kilojoule per mole. So now we have the second ionization potential, means the electron is removed from Mg plus. So it is forming Mg2 plus electron, and the second ionization potential is being given, that is 1450.73 kilojoule. And now we have been asked to calculate the energy required to convert all the atoms of magnesium to Mg2 plus 2 electron. So for this, the total energy will be equal to IP1 plus IP2 if I add first and second equations. So it will be equal to 737.76 plus 1450.73. So it is equal to 2188.49 kilojoule per mole. तो इसका मतलब क्या हुआ कि for the conversion of 1 mole of magnesium, how much energy is being required? 2188.49. Fine. And now we have been asked for 24 gram of magnesium vapors, and 24 gram of magnesium means 1 mole of magnesium vapor, because the molar mass of magnesium, that is 24. So the energy will be equal to 2188.49, which is nearly equal to 2188.5. So option number 1 is the correct answer. So I hope, students, this is clear to you. So let's move on to the next one now.